Hey everyone, today I'm going to talk about current dividers. Don't worry, it sounds technical, but it's actually pretty simple once you get the hang of it. So, what exactly is a current divider? Basically, it's a parallel circuit where the total current splits into smaller currents that flow throughout different branches. Each branch gets a share of current depending on its resistance. The lower the resistance, the more current it gets. This idea comes from Ohm's law and Kirchhoff's current law, which together explain how current moves in a circuit. Here are the main things to remember about current dividers. Current is inversely proportional to resistance. Less resistance means more current. The voltage across all branches are the same, and we use something called the current divider rule to figure out how the total current splits up. Alright, here's the rule in action. For two resistors in parallel, we can work out the current through each branch using these formulas. I1 equals the I total times resistor 2 divided by the sum of both resistors. This process is then repeated for I2. So basically, the current through one resistor depends on the other resistor's value. Kind of cool, right? Let's do a quick example. Imagine you've got two resistors, R1 and R2, in parallel. If you know the total current and the resistances, you just plug them into the formula to find out how much current goes through each one. This is super handy when you're designing circuits and need to make sure that the current is shared safely. Here is the example from the previous slide. The first step in calculating the current is to calculate the total resistance. The resistance is then needed to calculate the total current using Ohm's law. Once the total current is determined, we can use the current divider rule to calculate the current across the branches. You can double check you have the right values for the currents by adding them up to see if they equal the total current. See, it's pretty simple, right? Now, where do we actually see current dividers in real life? Think about your household lights. Each light bulb is like a branch in a parallel circuit. The total current from the power source splits between all the bulbs, but the voltage across each one stays the same. That's why they all shine equally bright. But we do have to make sure the total current doesn't go over what the circuit breaker can handle, and that the wires are thick enough for the load. So, to sum it all up, a current divider splits current between parallel branches. The smaller the resistance, the more current it gets, and the current divider rule helps us to calculate it easily. That's pretty much it. Thanks for watching. Hope that helped you understand current dividers a bit better.